Okay, here, now we are going to go the opposite way. We're going to try and split up this fraction into its respective partial fractions. So we're going to follow through this checklist in order to make sure that we do it correctly. So the first step, have we got an improper fraction? To check this, we need to check the degree of the numerator, the degree of the denominator. What's the highest power of x? Here we have x to the power of 4, here we have x to the power of 3. So this one is an improper fraction. The first thing we therefore need to do is long division to ensure that we can sort out the necessary parts. So, in order to do that, we need to quickly re-go over long division, which we're now going to do. You write out the numerator, you write out the denominator. If there was any term which didn't appear, so for example if there were no x squareds, you must put in a 0x squared just to make sure that that works. That will be a big trap in the exams. The next thing to do is to see how many times does x cubed go into x to the power of 4. Now obviously that is x times, so we have an x at the top and we bring our x down here to then multiply through and apply our long division. So x multiplied by all of this gives us x to the 4 minus 4 to the x cubed plus 4x squared. At this point, we need to always subtract. So we put in a subtraction sign. X to the 4 minus x to the 4 is nothing, so we don't need to worry about that. However, minus 4x cubed minus 4x cubed, that's 0. So again, there's nothing here. On this term, you've got 9x squared minus 4x squared, which leaves us with 5x squared. We now bring down the next couple of terms to make sure that we've still got something to divide into. So now we have 5x squared minus 17x plus 12. How many times does x cubed go into 5x squared? Well, actually it doesn't. So therefore we have finished our long division. This is our remainder, and we can then use that to put it in partial fraction form. So we have, when you divide it through, you get x whole terms, plus you get a fractional term. The remainder, which is this bit, over the denominator, which is still the same as the original. We can now apply our partial fractions to this fraction here in order to split that up even further into the next bit. To do that, we're going to need to come on to step 2. So for step 2, we need to work out how to convert this into our partial fractions. The first thing we're going to need to do is find out which terms are in the denominator. In order to do that, we need to factorise. Now this one's a cubic, which means we need to try and find a factor of that. The quickest way is going to be the fact theorem, or just by spotting things. In this case, we should be able to see that x is in each of these terms, so we can take out x as a factor and we're left with a nice quadratic. So we're looking at this fraction now. We've got an x taken out from the denominator. We have x squared minus 4x plus 4. Now hopefully we can factorise that again, and in fact x minus 2 appears in there. As a repeated root. It appears twice. If you wanted to, you could write that as x minus 2 squared. Like this. The top of the fraction is going to stay as it is for the moment. We're going to then try and unravel it into the various parts we need. So, once we've worked out the factors on the bottom, we know that this is going to break into parts. It's going to have an x part, and it's going to have an x minus 2 squared part. However, because x minus 2 is a repeated root, there's 2 of them, we also need to include just a linear version of the same thing. So we're going to have the x part, an x minus 2 squared part, and also just a simple x minus 2. So whenever you get a repeated root, don't forget that extra part. That will come up quite a lot. And at the moment, we don't yet know what these are going to be in terms of values, so we put in A, B, C. Obviously, you can use more letters if you need them. So at this point, we have an expression which is an identity, because we don't yet know what the values are, but we know that when we do find them, it's going to be true for all values of x. So once we've got that, we can now try and work these out. The quickest way is to multiply through, on the right-hand side, each fraction to make sure that we have the common denominator, and then we can just consider the numerators and make sure they're equivalent. So we're going to multiply through in order to get the common denominators. Now here, be very careful. We're looking for a common denominator of x times x minus 2 squared. Over here, we've already got x minus 2 squared, so we don't need to multiply by this x minus 2 and this x. We just need to multiply by a single x. Now please be careful with that, that can cause problems in the exam. If we do that, we get cx over x minus 2 squared. Now we're going to come to this term, and we need to multiply by another x minus 2, but not two of them, and an x. So we're checking really what we need to get from here to here on the left with the original denominator. So multiplying that through, we get bx times x minus 2. Now finally, for your a term, if you like, we have a over x. We need to multiply that by x minus 2 squared. And we get this final term here. Now if you notice, the denominators here are all the same as the denominator there. So it doesn't now matter. We can now just look at the numerators and make sure they add up together, because we can combine this effectively into one fraction. So we can form a nice identity for us. 5x squared minus 17x plus 12 is equivalent to a lots of x minus 2 squared plus bx times x minus 2 plus cx. Now many of you will jump straight from this line to this line. Please make sure that if you do that, you take into account the repeated roots and don't multiply by too many terms. Keep it as simple as possible. Now, once we get to here, we can look at step 3 on our checklist. Substitute values. In order to get values for a, b and c, we don't want all of them at the same time. So what we can do is put in a value which is going to turn two of these terms into 0. X minus 2 is a classic example. If we put 2 in there, that turns to 0, so we get 0 a's. Similarly, we have x minus 2 over here, so if we put a 2 into that term, we're going to get 0 and get 0 b's, which is going to leave us just with a c. So we can work c out very quickly just by substituting in x equals 2. Rule of thumb, look at the roots you've got, the linear parts. Whatever makes them 0 are numbers you are going to try. So the other one we will try is x equals 0, because this is obviously going to give 0 b's and 0 c's. Doing that, we have, letting x equal 2 first, we have x squared is 4 times 5 is 20, minus 34 plus 12, 0 a's, 0 b's, and 2 lots of x. Sorry, 2 lots of c for your final term. Now, we can add those up. We have 20 plus 12, that's 32, minus 34, minus 2 equals 2c. So we have c is equivalent to minus 1. And you can see by eliminating the a's and b's very quickly, we're able to get an expression for c super fast. Now let's consider where x equals 0, which will hopefully get rid of the b and c term and leave us with a. So letting x equal to 0, we have 0 minus 0 plus 12 on the left. 0 minus 2, so that's minus 2 squared, which is 4 lots of a. 0 b's, 0 c's. Finally, we divide by 4, and a is equal to 3. Now, this substitution has got us so far, but unfortunately we've got 3 terms, and we only had 2 different types of root, so we can't put in any other values. We now need to move on to step 4, coefficients. Now we need to work out what b is. Now b does not have a constant, it's just got an x squared and it's got an x term. So we need to look at one of those in order to get b involved. So I'm going to pick the x squared term because it's the highest degree, and that's often only applies to certain terms and will keep your working to a minimum. So, looking at the x squared terms. On the left hand side, we can clearly see there's 5x squareds and no other x squareds appearing. On the right hand side, however, we have to look at each bracket individually. This x minus 2 squared, when you square it, you're going to get an x squared term, which is going to be multiplied by a. So you've got a lots of x squared. Looking at the next bracket along, we're going to multiply that out, you're going to get an x squared, you're also going to get a minus 2x, but we ignore that because it's just an x term, we want an x squared term. So there's an x squared times by b, so that's bx squared. This final term is cx. There's no x squareds there, so we can ignore it. So we've now managed to create a little formula down here, which says a plus b is, of course, a x squared plus bx squared is 5x squareds. Now I've put x squareds here on the right. You don't actually need those, so we can rub those out. Because all we're actually interested in is the coefficients. They need to add up and make sure they are the same. So a plus b must be 5. We already know that a is 3, so hopefully we can deduce that therefore b is equal to 2. We've now worked out that a is 3, b is 2, and c is minus 1, which we can hopefully substitute back into our original identity. So we now know that a is 3, b is 2, and c was minus 1. You can either write minus 1 like that, or you could make the whole of that fraction negative. That works as well. Once we've done that, we've managed to sort that out for the overall fraction we have there on the right. So the answer to the actual whole question is x plus this fraction, which we can write like this. So instead, we write it as 3 over x, 2 over x minus 2, minus 1 over x minus 2 squared. We've therefore managed to sort this out, break this fraction up into its parts.